I wrote a bit of code a while back, and luckily I can still use it. So let me see. We have this defined. So what this does is just basically is like an if else. So I'm using a control variable. So if the compiler sees this anywhere in the code, then it will load a different section of the code, more or less. So in this case, I have an if define, and how I use the if define is simply so if it does sees the overflow, then it will load this bit of code all the way to the else bit. Otherwise, it will load the else bit of code. Good. So to start off with, I comment it out, which means we expect the things that are in this bit of code to appear. So I have an integer, and I assign the integer to the largest data type we can have in an integer. I have an unsigned int. Unsigned int means that, with the integer positive, negative whole numbers, it simply means that we are doubling the number of positive numbers by getting rid of the negative numbers. So it will be 0 to 2 to the power 16, right? So 2 to the power 16 minus 1, which is pretty much the number you got there, 0 to the number. Bool is true or false. It uses a byte, and then the long is 2 to the power what? 2, right? And unsigned long is the same. So long you've got both positive and negative. Unsigned long is similar to the integer, taking it from 0 to the maximum. You see the L here at the end to indicate is a long data type. The same you see the UL to indicate is the unsigned long data type. Then you have the double, same as float, but of course you do not have the precision of the after the decimal point. So float 2 to the power 16, and this an interesting one. You'll find this a lot when you program these Arduinos, and it's very much recommended. So integers is basically unsigned integer, but forcing the integers to take only 8 bits. So it's uint 8 underscore t to show its data type. It's inherited from the old C language, but of course works in here, and of course works with the AVR, so we're perfectly happy to use it. And with the uint, we get access to the actual binary because it's a byte, and we start with a B. So note the difference between the using the long, unsigned long, and the binary and other things. So byte also occupies 8 bits, which is 2 to the power 5, 2 to the power 8 with 255, but the actual 8 bits is actually 256, but we start with an index 0. So we call that similar to Boolean, 8-bit, and the short almost same as unsigned integer or integer data type, or same as integer data type there for the short. And in this case, in this particular case, in the case of architecture, the word is actually similar to that of the unsigned integer as well. Char 8 bits as well, or char data type, and unsigned char you've got, and I put a bunch of arrays in there. Now, how the code work? Remember, the setup loop runs only once, right? And then it jumps into a loop function. It will do nothing because I want whatever printed. So the word is a data type that represents the amount of information that most processors can actually fetch from the memory at a time. So you would have 16 bits having 16 bits, and depending on how smartly the processor is designed, you can have 32-bit word for a 16-bit processor and other things. So word, even though we've got byte and other things, like even these data types, mostly, even though they are similar, they're quite specific to certain architectures. So because we want to see, we don't want this printed over and over again. We want to have time to analyze it. I put it in the setup function. Okay, so if we jump into the setup, the first one that will be printed, because I've commented that out, is to find out, so we say if defined, well, whichever, let's go side by side. If we go into this bit of this block of the code, I like seeing that. If we go into this block of the code, we notice that what are we interested in? Simply just print something to show that we have the overflow on. Overflow, you notice I've already assigned some of them. I've assigned the maximum value ever to them. So I simply do a plus plus on them and just print them out. One thing that I may need to introduce is the serial monitor. So this is just the rate at which data is being communicated. So we can print onto the serial monitor. It's just the baud rate, right? I can explain that further in the next session if people are unclear and they ask, right? So we do a serial print and then I print the plus plus of the value to see what will come next. And I do the same for the other data types as well. So those ones that are already maxed out, we will see the overflow happens. Else, we just use the, for each data type, the size of actually gives us the size that the data type occupies in memory, or the variable occupies in memory. So for each variable, we print out how much it occupies in memory. So enough talking, lots of talking, but let's go in to see, run the simulation and see how it works. For this particular implementation, you don't need any proper circuit on there. All you need is just an Arduino, and we will see how it works on the serial monitor. So if we go into the serial monitor, enlarge it, we see that unsigned integer 1 byte, bool 1 byte, boolean 1 byte, byte 1 byte, integer takes 2 bytes, which is 16-bit, long 4 bytes, the 2, double same, float same, then the short similar as integer, and the word takes 2 bytes, and then the char takes 1 byte. So it actually shows us how much memory space it is taking. So I'm going to start the simulation and test the overflow, but before I test the overflow, let me clear the screen. So I clear the serial monitor and go back into the code and comment this out. Run the simulation again and see. So you see, for the integer, we have the maximum value, and then once we add the 1 to this number, it overflows to the negative. So you can't have any number higher than this in integers. If you want to, you need to use a different data type. Same for unsigned integer, because there's no negative, it overflows to 0, and the long overflows to negative, and similar to for the others as well, pretty much. Do I have any question at this point? That's the very first thing we explained, Hamza. So basically I'm using this as a control to control the output. So if you see the output now, is printing this block of code, which is that block of code. It's just a way to make life easy for me to explain things to you. But what the advantage here is that if the compiler says that this is defined, it will simply load this block of code, and then we can happily ignore the other part of the code, right? Because I'm saying if my variable is defined, run this part. Else, that is, if it is not defined, I get rid of it, because in this current time or present time, it is not defined. So if it is not defined and I run the simulation, it should append it there. So you notice that the output I get this time is completely different from the output I get this time. I mean, a bit of talking for you to add to your programming thing when you are doing this hardware if you've not used a similar thing before. Hamza, I hope that answers your question. What's the difference in using versus variable? Like I said, if it says this, it will load that bit of code. So there's a bit of optimization going on. Whilst if else, what you can do is later put this code in your Arduino IDE, download Arduino IDE, install it. When we get to talking about memory, you see a bit of it. Put this code in there, use simple if else, and then you look at the memory occupancy and decide how efficient or which one is. In this present instance, I prefer to do this because it is optimal for me. And the if else, how are you actually going to control it as well? Because it's just simply printing to the output. As far as the data types and memory occupancies are concerned, and honestly, that's the least significant part of the coding. I hope it makes sense, Hamza. Good. Thank you very much.